Great Red Spot. The Great Red Spot is seen by the Juno spacecraft via JunoCam in April 2018. The Great Red Spot is a persistent high-pressure region in the atmosphere of Jupiter, producing an anticyclonic storm that is the largest in the solar system. Located 22 degrees south of Jupiter's equator, it produces wind speeds up to 432 km per hour, 268 miles per hour. Observations from 1665 to 1713 are believed to be of the same storm. If this is correct, it has existed for at least 357 years. 1. It was next observed in September 1831, with 60 recorded observations between then and 1878, when continuous observations began. 2-3. 1 Observation history. 1.1 Exploration. 2 Structure. 3 Color and composition. 4 Mechanical dynamics. 5 Gallery. 6 See also. 7 References. 8 Further reading. 9 External links. Observation history edit. A wide view of Jupiter and the Great Red Spot is seen from Voyager 1 in 1979. The white oval storm directly below the Great Red Spot has the approximate diameter of Earth. Time-lapse sequence from the approach of Voyager 1 to Jupiter, showing the motion of atmospheric bands and circulation of the Great Red Spot. NASA image. The Great Red Spot may have existed since before 1665, but it could also be the case that the present spot was first seen only in 1830, and well studied only after a prominent apparition in 1879. The storm that was seen in the 17th century may have been different than the storm that exists today. 4. A long gap separates its period of current study after 1830 from its 17th century discovery. Whether the original spot dissipated and reformed, whether it faded, or if the observational record was simply poor is unknown. 5. For example, the first sighting of the Great Red Spot is often credited to Robert Hooke, who described a spot on the planet in May 1664. However, it is likely that Hooke's spot was not only in another belt altogether, the North Equatorial Belt, as opposed to the current Great Red Spot's location in the South Equatorial Belt, but also that it was the shadow of a transiting moon, most likely that of Callisto. 6. Far more convincing is Giovanni Cassini's description of a permanent spot the following year. 7. With fluctuations in visibility, Cassini's spot was observed from 1665 to 1713, but the 118-year observational gap makes the identity of the two spots inconclusive. The older spot's shorter observational history and slower motion than the modern spot makes it difficult to conclude that they are the same. 8. A minor mystery concerns a Jovian spot depicted in a 1711 canvas by Donato Creti, which is exhibited in the Vatican. Clarification needed. 910, part of a series of panels in which different, magnified, heavenly bodies serve as backdrops for various Italian scenes, and all overseen by the astronomer Eustachio Manfredi for accuracy. Creti's painting is the first known to depict the Great Red Spot as red, albeit raised to the Jovian northern hemisphere due to an optical inversion inherent to the Iris telescopes. No Jovian feature was explicitly described in writing as red before the late 19th century. 10. The Great Red Spot has been observed since September 5, 1831. By 1879, over 60 observations were recorded. 2. After it came into prominence in 1879, it has been under continuous observation. In the 21st century, the Great Red Spot was seen to be shrinking in size. At the start of 2004, it had approximately half the longitudinal extent it had a century ago, when it reached a size of 40,000 kilometers, 25,000 miles, about 3 times the diameter of Earth. At the present rate of reduction, it would become circular by 2040. It is not known how long the spot will last, or whether the change is a result of normal fluctuations. 11. In 2019, the Great Red Spot began flaking at its edge, with fragments of the storm breaking off and dissipating. 12. The shrinking and flaking fueled concern from some astronomers that the Great Red Spot could dissipate within 20 years. Citation needed. However, other astronomers believe that the apparent size of the Great Red Spot reflects its cloud coverage and not the size of the actual, underlying vortex, and they also believe that the flaking events can be explained by interactions with other cyclones or anticyclones, including incomplete absorptions of smaller systems. If this is the case, this would mean that the Great Red Spot is not in danger of dissipating. A smaller spot, designated oval Ba, formed in March 2000 from the merging of 3 white ovals, 14, has turned reddish in color. Astronomers have named it the Little Red Spot or Red Junior as of June 5, 2006. The Great Red Spot and oval Ba appeared to be approaching convergence. 15. The storms pass each other about every 2 years, but the passings of 2002 and 2004 were of little significance. Amy Simon Miller, of the Goddard Space Flight Center, predicted the storms would have their closest passing on July 4, 2006. She worked with Imke de Pater and Phil Marcus of UC Berkeley and a team of professional astronomers since April 2006 to study the storms using the Hubble Space Telescope. On July 20, 2006, the 2 storms were photographed passing each other by the Gemini Observatory without converging. In May 2008, a third storm turned red. 17. The Great Red Spot should not be confused with the Great Dark Spot, a feature observed near the northern pole of Jupiter in 2000 with the Cassini-Huygens spacecraft. 18. There is also a feature in the atmosphere of Neptune also called the Great Dark Spot. The latter feature was imaged by Voyager 2 in 1989 and may have been an atmospheric hole rather than a storm. It was no longer present as of 1994, although a similar spot had appeared farther to the north. Close-up of the Great Red Spot taken from about 8,000 kilometers, 5,000 miles, above it July 11, 2017. On February 25, 1979, when the Voyager 1 spacecraft was 9,200,000 kilometers, 5,700,000 miles, from Jupiter, it transmitted the first detailed image of the Great Red Spot. Cloud details as small as 160 kilometers, 99 miles, across were visible. The colorful, wavy cloud pattern seen to the left, west, of the red spot is a region of extraordinarily complex and variable wave motion. The Juno spacecraft, which entered into a polar orbit around Jupiter in 2016, flew over the Great Red Spot upon its close approach to Jupiter on July 11, 2017, taking several images of the storm from a distance of about 8,000 kilometers, 5,000 miles, above the surface. 2021, over the duration of the Juno mission, the spacecraft will continue to study the composition and evolution of Jupiter's atmosphere, especially its Great Red Spot. 20. Structure it. Approximate size comparison of Earth and the Great Red Spot. Jupiter's Great Red Spot rotates counterclockwise, with a period of about 6 Earth days 22, or 14 Jovian days. Measuring 16,350 kilometers, 10,160 miles, in width as of April 3, 2017, Jupiter's Great Red Spot is 1.3 times the diameter of Earth. 20. The cloud tops of this storm are about 8 kilometers, 5.0 miles, above the surrounding cloud tops. 23. Infrared data have long indicated that the Great Red Spot is colder, and thus higher in altitude, than most of the other clouds on the planet. 24. The upper atmosphere above the storm, however, has substantially higher temperatures than the rest of the planet. Acoustic, sound, waves rising from the turbulence of the storm below have been proposed as an explanation for the heating of this region. 25. Careful tracking of atmospheric features revealed the Great Red Spot's counterclockwise circulation as far back as 1966, observations dramatically confirmed by the first time-lapse movies from the Voyager flybys. 26. The spot is confined by a modest eastward jet stream to its south and a very strong westward one to its north. 27. The winds around the edge of the spot peak at about 432 km per hour, 268 miles per hour. Currents inside it seem stagnant, with little inflow or outflow. 28. The rotation period of the spot has decreased with time, perhaps as a direct result of its steady reduction in size. 29. The Great Red Spot's latitude has been stable for the duration of good observational records, typically varying by about a degree. Its longitude, however, is subject to constant variation. 30. Because Jupiter does not rotate uniformly at all latitudes, astronomers have defined 3 different systems for defining the longitude. System 2 is used for latitudes of more than 10 degrees and was originally based on the average rotational period of the Great Red Spot of 9 hours 55 minutes 42 seconds. 31. Despite this, however, the spot has lapped the planet in System 2 at least 10 times since the early 19th century. Its drift rate has changed dramatically over the years and has been linked to the brightness of the south equatorial belt and the presence or absence of a south tropical disturbance. (32) Color and composition edit. Clockwise from top left, Hubble image of visible spectrum. Infrared from the Gemini Observatory, multi-wavelength composite of Hubble and Gemini data showing visible light in blue and thermal infrared in red, ultraviolet image from Hubble, visible light detail. It is not known what causes the Great Red Spot's reddish color. Hypotheses supported by laboratory experiments suppose that it may be caused by chemical products created from the solar ultraviolet irradiation of ammonium hydrosulfide and the organic compound acetylene, which produces a reddish material, likely complex organic compounds called flens. (33) The high altitude of the compounds may also contribute to the coloring. 34. The Great Red Spot varies greatly in hue, from almost brick red to pale salmon or even white. The spot occasionally disappears, becoming evident only through the red spot hollow, which is its location in the South Equatorial Belt, SEB. Its visibility is apparently coupled to the SEB. When the belt is bright white, the spot tends to be dark, and when it is dark, the spot is usually light. These periods when the spot is dark or light occur at irregular intervals. From 1947 to 1997, the spot was darkest in the periods 1961 to 1966, 1968 to 1975, 1989 to 1990, and 1992 to 1993. 5. Jupiter's clouds taken on June 27, 2019 by Hubble's Wide Field Camera 3. 35. Color animation of Jupiter's cloud motion and circulation of the Great Red Spot. Mechanical dynamics edit. There is no definitive theory as to what causes the formation or color of the Great Red Spot. Laboratory studies are examining the effects that cosmic rays or UV light from the Sun have on the chemical composition of the clouds of Jupiter. One question is whether the Sun's radiation reacts with ammonium hydrosulfide in the planet's outer atmosphere to create the deep red color. 36. Research suggests that the storm produces extreme amounts of gravity waves and acoustic waves, owing to the turbulence of the storm. The acoustic waves travel vertically upwards to a height of 800 kilometers, 500 miles, above the storm where they break in the upper atmosphere, converting wave energy into heat. This creates a region of upper atmosphere that is 1,600 K, 1,330 degrees Celsius, 2,420 degrees Fahrenheit, several hundred Kelvin warmer than the rest of the planet at this altitude. 37. The effect is described as being like crashing ocean waves on a beach. 38. The reason the storm has continued to exist for centuries is that there is no planetary surface, only a liquid core of hydrogen, to provide friction. Circulating gas eddies persist for a very long time in the atmosphere because there is nothing to oppose their angular momentum. (39) Winds in Jupiter's Great Red Spot. 40.